this video we'll be solving a problem from LeetCode which is called house robber. So let's start by understanding the question. So there is a street on which there are houses which are placed adjacent to each other in this manner. So assume that this is a street and then we have five houses on that street, and then a robber is supposed to steal the houses on this street in such a manner that he can earn or he can steal the maximum amount of money. But there is a constraint which has to be kept in mind, which is that you cannot steal in two houses which are adjacent to each other. So for example, if the robber decides to steal at house number 1, then he cannot steal at house number 2. And if he decides to steal at house number 4, he cannot steal at house number 3 or house number 5, and so on. So like this constraint has to be kept in mind whenever a theft has to be committed at a particular house. So now let's look at the method signature and at the method which has to be coded. So we see that the input is an array of numbers, and like these are like the houses and the amount of money in each house, which is the input, and the output is a single integer value, which is like the maximum amount of money which can be stolen, keeping the constraint in mind. So let's look at the examples and understand them. So we have a street on which there are four houses with money in them as 1, 2, 3 and 1 respectively. So in order to maximize the theft output, the theft has to be committed at house number 1 and at house number 3, and the total will come out to be 4. So in all other cases the value will be less than 4. And if I look at example 2, then there are five houses on the street, and in order to maximize the theft amount, the theft has to be committed at house number 1, at house number 3 and house number 5, and in this case the total comes out to be 12. In all other cases, with the constraint in mind, the value will be less than 12. So this is what the problem is all about. Now next we will understand and look at the possible solution for this. Problem is a very good example of a problem which can be solved using dynamic programming. So let's spend few minutes to understand what this programming or problem solving technique is all about. So dynamic programming is the main idea behind this programming technique is to divide your problem into sub problems. So you have to look at your problem, you have to find out a sub problem, and the sub problems should be such that you can divide it further into sub problems and so on until you reach a point where the solution is very trivial, and then that solution can be used to build a solution to a bigger sub problem, and the combined solution can be used to find a solution to a still bigger sub problem, and this process has to be repeated till you reach your intended solution. So let me mention few points about DP. So we denote dynamic programming by DP here, and then there are two ways or two approaches to solve the problems based on dynamic programming. So one is like the bottom up approach, and the other is top down approach. So bottom up approach is typically a iterative way of solving the problem, and top down is a recursive way of solving the problem. So in this video we'll be talking about the bottom up approach for DP. So let's first find out what the sub problem will be in this case. Okay, so this part is something which is very important, and like you have to spend some time to understand and to find out what could be possible sub problems. And so in this case, a good sub problem can be this, that given a certain number of houses, you have to find the maximum stolen amount. So when I say certain number of houses, it doesn't have to be the houses which are given in the question. For example, if there are 5 houses on that street, so this certain number will be definitely less than that, because 5 is something which you want the answer for. So let me write down this sub problem here. So given a certain number of houses on the street, find the max stolen amount. So now with this sub problem idea in mind, let us look at what it means. So assume that this is your street and you have, say, 5 houses here: first, second, third, fourth, and fifth. And then sub problem will be, just considering the first house. So this is your basic sub problem to which you should find the answer first, and then use its solution to find the solution to bigger sub problems. So this should be your first sub problem. Then your second sub problem will be to find the maximum stolen amount when you have house 1 and house 2. When you have solution to this, then you have to find the max stolen amount when you have house 1, 2, and 3. And then the next sub problem will be to find the maximum stolen amount when you have houses 1 to 4, and then when you have houses 1 to 5. So basically you have second, third, fourth, and fifth. So these are your sub problems, and when you have found a solution to your fifth sub problem, then you have the overall solution to your question. So in order to do this, let's define two functions. So first will be, say, mi, which is nothing but money which is kept at a particular house. So money kept at ith house, and this is nothing but given as input to you. So you already have this function in a way in form of the input array which you are getting. And then the other important function is ai, which is the maximum amount of money which can be stolen, excuse me for my bad writing, by stealing from first house till ith house. So mi is something given to you, ai is something which you have to find out. And if you are able to find these the value of ai with I ranging from 1 to 5, so a5 will essentially give you the solution. So now next we will define how to define this function ai. So we'll be looking at that next. Now before looking at the formal definition of the function ai, let's first look at example of a sub problem and see how we can solve that sub problem. So again, we have this street on which we have 5 houses, and let's try to solve the sub problem a4 as we have defined it before. So this is the maximum amount which can be stolen by stealing from houses 1 to 4. So now there are two choices for the robber when he's stealing from houses 1 to stealing at houses from 1 to 4. So he can either steal house 4 or he will not steal at house number 4. So if he steals at house number 4, then we know from the condition that he cannot steal at house number 3. So he will steal at house number 4, and he can steal from houses number 1 to 2. In the case he is not stealing at house number 4, he'll be stealing from houses 1 to 3. So we have two cases, and in order to maximize the amount which can be stolen, we have to take the max value out of these two. So it will be max of whatever money is kept at house number 4, and then the maximum amount of money which can be stolen by stealing from houses 1 to 2, and the other option for him is to steal uh, the houses 1 to 3. And why I have mentioned A, because this is like the maximum amount. Already we have defined this function as the maximum amount of money which can be stolen from one house to another. So in this case from house 1 to 3. So now looking at this example, we can finally formally define our value of the function AI, which is nothing but AI is equal to max of AI minus 2 plus mi, and so this is the first value which has to be compared, and the second value which has to be compared to find the maximum value is a I minus 1. So if you substitute 4, you will get a 2 plus m4 comma a 3. So now if you look at this carefully, in order to find the solution for A4, you are relying on solutions of subproblems which you already have found the solution for. So for A4, you are relying on M4 which is directly available to you, and then you are relying on solutions for A2 and A3 which are the subproblems which you have already found out a solution. So now this is the formal definition for AI. And now let's look at the example which has been given in the question, where we have 5 houses on the street with values as 2, 7, 9, 3 and 1, and by simple substitution you will be able to find out the value of A5, which is what we are looking for. Now one more interesting and important point here is that in order to solve the DP problems, typically the table size for ease or for convenience, at least in this case, will be to have a size of array which is like one more than the number of houses which you have. So in this case you would like to have the array size of 5, 1 plus 5 basically. So 1 is to store the 0th case where you are not stealing any house, and then you have other elements to store the value for the rest 5 houses. So in this case the size of your table should be 6. So basically you will have values from A0 to A5. Yeah, so now let's look at the value for A0. So A0 means you are stealing nothing, so the value of A0 will be 0. Now A1 is that you are just stealing the first house, so that is the only option which you have, so it will be equal to M1, which is equal to money kept at house number 1, which is 2. Then A2 is equal to, now we will use the formula which we have derived here. So A2 is equal to max of A0 plus M2 and A2 minus 1, which is 1. And then if you simply substitute the values, the value will come out to be 7, because A0 is 0, M2 is 7, and then A1 is 2. So max of 7 and 2 is 7. So similarly, if you substitute for other houses, the value of A3 will come out to be 11, the value of A4 will come out to be 10, and the value of A5 will come out to be 12. And as we have already seen that A5 is the solution which we are looking for, which is the solution of the main problem. So in this case 12 is the maximum amount of money which can be stolen. So this is the basic idea of solving this problem, and with this discussion and approach in mind, you can now convert this solution into a code, which we'll be doing as a next step. So let's now move on to the coding part of it. Where to code the solution, but if you have followed the solution and followed the discussion so far, you should be easily able to write this code in any other language of your choice. So let's start looking at the code. So I have used Java, and then this is the input array, which is nothing but the placement of houses on the street with money in each of them. And then as we discussed, that the DP table, which is the array A, should be of a size which is one more than the houses on the street. So it is like nums dot length plus 1. And now let's come to this line where we are initializing the first two entries of our resultant array, or the DP table array. So A0 is 0 because if there are no houses on the street, you cannot steal anything. And A1 is initialized to num0, which means that if there is just one house on the street, you can steal only that house and you don't have to worry about the constraints. Now moving on to the rest, the remaining houses, which are like houses 2 to 5, we initialize this array, we initialize this variable I with 2 and run it till nums dot length. And let me write down the formula which we derived for finding a solution to our sub problem. So AI is equal to max of nums I minus 1 plus I minus 2 AI minus 1. So what happens within for loop is essentially continuous calculation of the sub problems. So this is the same formula. If you are wondering why there is this why there is this 1 unit difference between nums and A, so this is because our DP table array is like of size which is one more than the number of houses on the street. So for example, if this is 0 1 2 3 4 5, which is equal to 6, and our nums, which was equal to m in our discussion, is of size 0 1 2 3 4, so the first house is index 1 and so on. So that's why there is this difference of I and I minus 1. And now let's spend time on looking at the complexities. So time complexity is simply ON, because where n is the number of houses on the street, because we are simply iterating over this nums array one time. And then space complexity also is ON, because we are just initializing a single array A, which has the answers to the sub problems. So when you are done iterating over the for loop, the last entry in this particular array will hold the result of the last sub problem, which is actually the maximum amount of money which can be stolen when all the houses on the street are being considered for robbing. So with this, I think we can end our discussion here, and I hope that this video and the entire discussion of the solution which we had was useful. So thank you so much for listening to this, spending your time with us. Thank you.